In this video, we are going to be covering section 6.5, which is factoring binomials. Now, before we get into the actual factoring of binomials, there's some groundwork that I want to lay here. When we get into factoring in general, this is the last big idea with just the general application of factoring. What I want to do is kind of give an overview of what we've done so far. Whenever we have a factoring problem, what is the first thing we always want to ask ourselves? And in the last couple of videos, it was always, is there a GCF? So when we're looking at a factoring problem, GCF should always be your first thought, or at least your first attempt when you're doing a factoring. After that, there's going to be three main categories that the polynomial is going to fall into. You could have a polynomial with 4 terms. You could have a polynomial with 3 terms, or you can have a polynomial with 2 terms. Okay. When you get into when you're done with this section, I would put this flow chart on a note card or a piece of paper, have it out with you when you're doing these problems, so you know what to think through and what to be attempting in each specific problem. Now, when we had 4 terms, what method did we have for that? That was grouping. When we had 3 terms, remember we had a couple options. It wasn't a necessity, but I was pushing try the perfect square trinomial first. So for 3 terms, I would try a perfect square trinomial. If that's not there, or if you draw a blank or you don't like it, then you had guess and check. Now remember, if you had other methods for that, you can feel free to use them. Just please be cognizant of how long they are taking you, because you don't want to get bogged down by doing a problem 3 times longer than it needs to be. Now, with 2 terms, there are 2 types of factorings that we are going to be talking about today, and they are disjoint from each other. Here, if you didn't get this, you can always go to guess and check. With these 2 forms of binomial factoring, it's either one or the other. Okay, the first one we're going to look at is a difference of squares. Okay, in order to do this, we need to have a grasp on the list of perfect squares. Now, this doesn't mean that you have to have this memorized, because you can easily, do this in your head or use a calculator. But if you do have these memorized, life is a lot easier. You can recognize them without having to do a bunch of calculation. If you're struggling with having perfect squares memorized, this is something that, again, you could put on a note card, put on a sheet of paper, and have it out with you while you're doing your work. I would list the numbers 1 through probably 20. I'm going to go up to 13 here just for the sake of space. Okay, we're going to call those numbers n. They're numbers. What happens when I square those numbers? Okay, while you're building this, use your calculator if you need to, but try to have these memorized. And if you can, I would have them memorized out to 20 squared, okay? But with these, 1 squared is 1, 2 squared is 4, 3 squared is 9, then 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, okay? Now, what we're using that for is the square root of 36 is 6. Square root of 100 is 10. Square root of 144 is 12, and so on. Now, we will, in a couple minutes, talk about cubes, okay? But right now, let's work with the squares. Now, if we're factoring a difference of squares, what does that look like? Let's say we've got 25x squared minus 49. And I just say factor. Okay? Now, first, always, looking at this, see if there's a GCF. In this case, there's not. Okay? So since there's 2 terms, I tried that, it didn't work. I go down here. Now, remember, we had a couple things to look for perfect square trinomial. We made that list. Here, the name is the list, okay? It has to be a difference, and it has to be two perfect squares. So if we're looking at this, is that a difference? Yeah. Perfect squares. What's the square root of 25x squared? 5x. What's the square root of 49? 7. Okay? There was a difference, and these are perfect squares. Now, how do we factor that? Watch carefully, because this is very tricky. I'm going to take these. I'm going to add them, and I am going to subtract them. I'm just kidding. That's not tricky. That's all there is to it. You're done. As always, if you wanted to check that, you would just FOIL that back and get into there, and you're good to go. Okay, let's look at a few more of these. Let's say we have that. Okay, again, there's no GCF. It is a binomial. There's a difference. Now, in terms of perfect squares and fractions, again, it's not 4/9 that you're worried about. There's a numerator and a denominator. 4 is a perfect square and 9 is a perfect square. You can work with them separately. So if I'm taking the square roots, square root of x squared is x. What do I square to get x squared? Square an x. And then square root of 4 is 2. Square root of 9 is 3. There's your square roots. I add them. I subtract them. And there we have it. How about something like this? Okay, there's no GCF. It's two terms. It's a binomial. So is it a difference of squares? Is it a difference? No. I can't factor a sum of two squares. When you see something like this, prime. That's all there is to it. Okay, again, it has to be a difference of squares, not a sum of squares. Okay, how about clear the board a little bit? How about something like this? Okay, now, first off, is there a GCF? In this case, there's no GCF. Now, difference of two squares. For this pattern to work out, we want to have the difference in the middle. There are a couple ways that we can work with this. Don't look at this and say, well, it's sum. They have different signs. So this is technically a difference, but we got to be careful when it's laid out like this because we want the pattern to work for us. So we need the negative in between. Now, what the textbook typically shows you is to factor out a negative and change it to this. And then you have a difference of squares right there. That's perfectly fine. But then you got this negative hanging out in the front. I want to avoid that if I can. I want to make this as simple as possible. So what I like to do is simply take these two terms and switch them. That got the negative in the middle as well. This is perfectly fine. We would still have to factor that difference of squares. But again, then you have that negative hanging out in front. Okay. Again, it's perfectly fine. To me, that's more complicated than it has to be. So if I go here, I'm going to then say square root is 2x, square root is 9, add them, subtract them. And there we go. If you did like this method with the taking the negative out, that's fine. But then that negative has to be carried out into the answer. Square root is 9, square root is 2x, add them, subtract them. This or this are acceptable. Okay, there's no one to say, no one will say that this is better than that or that is better than that. They're both acceptable. To me, this is a little nicer though. Okay, but you use whichever method you like. How about something like this? p to the fourth minus 16. Okay, seems pretty simple at first. However, watch how this evolves. First of all, no GCF. Secondly, this is a difference of two squares. Now, when we're taking the square root of like an x squared, notice what we were doing. We were taking that square and dividing it by 2, so it's an x to the first. We're doing the same thing here. Okay, so if we take the square root of p to the fourth, we get a p squared. Square root of 16, 4. Add them, subtract them, and there you go. Now, why would I mark that wrong? Think about it. I factored it. However, notice I have another difference of squares right here. I'm not done factoring. This is a right answer, but it's not a complete answer. We stopped too soon. So we look at it again. This right here is a sum of two squares. I can't do anything else with that. But this, square root is p, square root is 2, add them, subtract them. Don't forget, this is still part of it. And there's your answer. Okay? So always be cognizant of these difference of squares. Difference of squares can happen anywhere because it's binomials. Guys, when we did grouping, what did we end with? We ended with 2 binomials. Maybe those are difference of squares. When we did guess and check, 2 binomials. Maybe they were difference of squares. Okay? Whenever you factor using this, or this, and you still have exponents there, stop and think about difference of squares. If there's no exponents, then you're pretty safe to say I'm done. Okay? But if there's still exponents, really stop and think if you can take it that next step down using a difference of squares. Let's do one more like this, and then we'll move on to something a little different. Let's say we have something like this. Now, what's different about this example is, what do we have? We have a GCF. However, these are perfect squares, aren't they? What I see a lot of people do is they say, well, that's a GCF, but they're perfect squares. I want to do that. If there's a GCF and they're perfect squares, taking the GCF out will not mess with the fact that you have perfect squares. It's not going to hurt you in any way. Watch what happens. If I take the 9 out, don't I still have 2 perfect squares? That's never going to change. If you start with perfect squares, take a GCF out, you'll still have perfect squares. Take the GCF out, okay? And then here, square root is x, square root is 3, add them, subtract them. Don't forget, 9. And there we go. That is difference of squares. Very simple, but as you saw here, it can be tricky if we're not looking for it. So always look for it, not just when you're given a binomial. Binomials happen everywhere. So look for it either at the beginning here, or maybe at the end of these, or at the end of this. Now, the next thing that I want to talk about is another type of binomial that we can factor. There's difference of squares, or I'm going to come down here, sum or difference of cubes. Now notice this can be a sum or a difference, but we're going to be working with 2 perfect cubes. Okay, now perfect cubes are not typically as familiar as squares are. So this will definitely be useful just so we can get comfortable with these numbers. So let's go through it. If I'm cubing a 1, I get a 1. 2 cubed is 8. 3 cubed is 27. 4 cubed is 64. Okay, notice, careful here. 64 and 64, they're both a perfect square and a perfect cube. Be careful and be aware of what you're working with at that moment, squares or cubes. 5 cubed is 125. 6 cubed is 216. Then keep going. 343 for 7. 512 for 8. 729 for 9. and then 1,000 for 10. Honestly, I would probably stop there with cubes. I wouldn't go all the way to 20. Not that you can't, but we're probably not going to be seeing those, so I wouldn't worry too much about those. These you do not have to memorize. You don't have to memorize that the cube root of 343 is 7, but be familiar. I want you to be able to see 343 and say, something's fishy about that, or there's something special about that number. But if you can have as many of these memorized, things will be a lot easier for you. So again, give it a shot. Make that note card, have it out, look at it while you're doing all these problems. So let's look at how this is going to work. I'm going to start with a simple example. Let's say x cubed plus 8. Okay. Now, we look at this, no GCF. Then I say, well, wait a minute, there's 2 terms. Is that a difference of squares? No. How about the sum or difference of cubes? Honestly, I don't care what sign is here. These need to be perfect cubes, okay? Now, there's a pretty drawn out pattern that we need to know for this, but I want you to realize that this is just a pattern of numbers that we're trying to recognize and utilize. There's no deep meaning or deep discovery that's involved here. It's just how the numbers are going to work out in a certain pattern, okay? So first thing we do with perfect cubes, I'm going to take the cube roots of these. Cube root of x cubed is x. Cube root of 8, 2. Simple as that. I'm going to create a binomial with those. Then I need to create a trinomial. Okay. Now, these 2 right here, I am going to call the first and the second, just to help us navigate this thing, okay? So first thing we do is cube roots. Now this is my first and this is my second. What I'm going to do is I'm going to take my first and square it. I'm going to multiply the first times the second, and then I'm going to take my second and square it. Okay, now what does that look like in application? My first cube root was x. Square it. These 2 multiply. X times 2 is 2x. And then I take this and I square it. That's how you build your trinomial. Okay. Now, again, this is something that I want you to study, memorize, but don't look at it and just try and memorize it by staring at it. Use it. Talk yourself through it. Okay, cube root of x cubed is x. Cube root of 8 is 2. X squared. X times 2 is 2x. 2 squared, 4. Okay, talk yourself through these problems. Now, if you'll notice, I'm missing signage. There's no pluses or minuses anywhere. So that still needs to be filled in. What we use to fill that in is the word SOAP. Okay, and that stands for same, opposite, always, positive. Okay, now what do I mean by that? I started with a plus. I have the same, I have the opposite. This is always positive. And now this is factored. Okay, so recap, cube root, square, multiply, square. And then same, opposite, always positive, SOAP. Let's look at one more. How about that? Okay. Now, first off, no GCF. I go with 2 terms. That is a difference, but this isn't a perfect square. So difference of squares is out. I'm going to try sum and difference of cubes. So again, I don't really care about that right now. Cube root is 3x. Cube root, now remember, cube root of 64 is 4. Okay, be careful with the 64. Now, that is my binomial. Okay. Pause the video and see if you can fill out that trinomial. Okay, now, for that trinomial, I'm going to look at these cube roots. I start by squaring this. 3x squared is 9x squared. Remember, you're squaring both components of that, the 3 and the x. Then I need to multiply these. 3x times 4 is 12x. Then I square this. 4 squared is 16. And now, SOAP. Same, opposite, always positive. And there we go. If you wanted to check it, you can always redistribute that, distribute the 3x, distribute the -4. You'll notice that a lot of terms just cancel out in the middle, and you'll be left with those two right there. Okay, so that is pretty much it for section 6.5. Very simple stuff, but especially with these cubes, make sure you study that pattern. And as always, guys, just keep drilling, keep practicing, and watch out for those difference of squares at the beginning of a problem and at the end, especially when you have exponents still on some variables. Okay, so keep working hard. I'll see you next time.